What you want to do is set one side equal to 0. I'm going to pick on the little guy again. Fun. By doing so, I'm going to move the 2 cosecant to the right. At the same time, I'm going to move the plus root 2 other stuff. So I'm going to get 0 equals cosecant x plus root 2 cosine cosecant x. Now I'm set up with 2 terms equaling 0. So I want to factor. At this point, I'm going to factor out a cosecant. When I factor out a cosecant, I'm left with 1 plus the square root of 2 times cosine of x, all equals 0. Which now means that I have 2 terms equal to 0. Go ahead.
Wouldn't it be 2 plus square root?
When I subtract 2 cosecant,
Oh, okay.
I subtract out here. Does that make sense? So now I set them both equal to 0. So I have cosecant of x equals 0. And I'm going to write it as cosine of x equals -1 over root 2. Is everybody okay with me simplifying it quickly like that? I've done that a bunch of times with other problems. I'm hoping it's still not a big deal. So again, when I'm solving these inverse trig functions, if you want to, you can solve them while they're in their inverses, but if you recall, it's always easier to change them into their standards. Cosecant is the inverse of sine. So if I take the inverse of this side, I get sine of x. But what's the inverse of 0? That's undefined. Will sine ever be undefined? No, sine is a continuous function. Sine will never be undefined. So this is, no, not going to happen. All right? Yes?
Couldn't you, at the beginning,
No. You got to set aside equal to 0 because sometimes you have to, if you do factor out one of those things and you divide everything out, you will eliminate a possibility. There is another problem that we did like this a couple days ago where you divide everything out by tangent and you eliminated one of your possibilities. Always set aside equal to 0 and then factor from there. Did I answer your question you were about to ask me?
yes.
You're not the only one that's asked that. Could you tell?
Yeah.
That was the answer in a can ready to go because I knew someone was going to ask it. Yeah, if you go back, I forget what problem it was. It was on the other side of this worksheet. If you divide it out by something, you eliminated a possibility. I think that other problem, it canceled out something, wound up being like a pi over 3. That was an additional possibility. You always want to set aside equal to 0 when you have these equations. That's how you're always guaranteed to find all possibles. Now, in this case, there isn't one anyway. It's kind of dumb luck that it works that way. It does work by doing it the way you did it, but bear in mind that there is a possible time that it will happen something else. Okay. On the other side, yeah, Richard?
You just divide without saying.
Yeah. Set it equal to 0. Always set these equal to 0 before you do anything. Then you factor. All right. On the other one, what triangle are we in with the 1 and root 2? It's the 45s. Where is cosine negative then? If 45 is going to be my reference angle is at pi over 4. Cosine's negative in which 2 quadrants? What was that?
1 and 4.
Cosine's negative in 1?
Negative would be 2 and 3.
Yeah. So, so what is that? 3 pi over 4 and 5 pi over 4? And I believe these problems were asking us to list the possibles within a revolution. And there's my 2 answers. Okay. That was 8, correct? You guys wanted to see, that was 9. You guys wanted to see 8 too, I believe?
Yes.
Or I forgot, you had your hand up. What did you have a question on?
I was gonna ask you for number 8. I just did it though, because I did just the way that you did, just like now and stuff. But
Yeah, your idea here is you want to factor out the cosecant. Okay? So when you factor out your cosecant in this problem, you have cosecant of x times secant of x minus 2. So again, you have the same idea where you wind up with cosecant of x is 0. You're going to get a no solution here. It's the same problem we just did. The inverse of that is sine, so we can just go ahead and do that. Here you have secant of x is 2. The inverse of secant is what? Yes, sir.
How did you pull that? Oh, it's factoring, okay, I was trying to take it to the next step, like, alright, makes sense.
A lot of times, the other suggestion that for students, if you forget about the factoring part here, write this as x, y, minus 2y. You can factor out a y, x minus 2. See what I'm saying? If you set it up that way, you're using kind of like that u substitution again, just to make it a little bit easier. Secant's the inverse of which trig function? Cosine? It doesn't. Yeah, I know. Story of my life. And again, now I'm cosine of x is equal to a half. What triangle do we get cosine equal to a half? 30, 60. And you're right, it's at 60 degrees, so that is pi over 3. Cosine is positive in which two quadrants? 1 and 4. So my reference angle is at pi over 3, and then in the fourth quadrant it is?
5.
Very good. Yes, sir.
Why can't you take the inverse of 0?
Remember, when you're talking about the inverse, anything to the negative 1 power means it's not happy in the numerator, so it becomes 1 over 0, so it becomes undefined. Not necessarily. When you have tangents, remember when you're dealing with tangents, if it's the tangent, I'll get you 1 second, Christina. If you have the tangent of x is equal to 0, and I want to find the cotangent, that would be undefined. But if the cotangent was undefined, that means the tangent is 0. Because this is 0 over 1, and this is 1 over 0 when you're on the quadrantals. So sometimes with tangents, you could get a 0 or an undefined, depending upon which quadrantal you're on, pi over 4, 3 pi over 2, 0 over pi. You can mess around with some of those. Okay. Sine will never be undefined because it's always continuous. There isn't any aspect of stop. Same thing with cosine. Yeah?
Okay, so what are the situations where you would add pi n or like 2 pi n or whatever?
When you're talking about those with general solutions, when you're looking at a general solution style problem, in the last example we just had was pi over 3, and it was at 5 pi over 3. Those were my two solutions. In this example, if it was a general solution, it's just looking for those two values, you start here and ask yourself, well, is there a constant amount that I add to get to here? And then you add from here to here? There's no constant amount that always gets me to the same place, back and forth. That means this would have to be plus 2 pi n, and this would be plus 2 pi n. The times that it is not 2 pi n is generally occurring in one of two cases. Tangents, because they're both positive here and here, or they're negative here and here. They're always a pi apart. And the only other case that this could happen, where this would be a plus a pi n, it's usually with tangent, if you are on your 45s, pi over 4 all the way around, you create a square. All of these values are the same distances apart. This is when it's plus 2 pi, plus pi over 2, plus pi over 2, plus pi over 2. That only, when you're talking about general solution. Remember, general solution is you want to write it as simplistic of an answer as possible. You want to list out the fewest number of angles as you can. So if it's a tangent problem, you usually only have to list out one, because the other value is pi away. Unless it's a plus or minus, then you have to list out two of them. Okay? If it does not have a constant value, if it's a pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, if you're listing out all four of those, there is no real constant value to get you between every one of them. It's when you have to tack on your 2 pi n's. Right? So it's a matter of, again, can you place it on your triangle? not triangle, can you place it on the unit circle and understand that's not a constant value, because it's forming a rectangle, just things like that. I said rectangle. A rectangle, a square is a rectangle,
Yeah,
a
I just-
rectangle isn't a square. Yeah, squares. But not all rectangles are squares. But every square is a rectangle.
Will you square?
Sure. Yes, sir.
You can try to get rid of the, 3 squared, right? And just,
You're on number 3, you said?
yeah.
5 cosine?
Yeah.
What are we doing?
Here's a general solution problem. Let's walk through one. Did you set the side equal to 0 from the right, move 3 cosine over? All right.
Well, first I just like,
Sorry, go ahead.
I squared everything just to get rid of the root, just to look at it nicely. Doesn't that work? And then I end up with cosine squared, and
Why not?
Set aside equal to 0. Right off the bat, set aside equal to 0, because then you wind up with cosine of x is going to equal root 3 over 2. By squaring both sides, you're creating the difference of squares, or no, it's like the sum of squared, or junk squared, excuse me. And then you wind up having to factor all that through. It's just not going to get you anywhere.
I didn't really get very far. I just thought those.
Always set aside equal to 0, because then right off the bat, you wind up with 2 cosine minus root 3. You can add the root 3 divided by 2, and you have cosine value of root 3 over 2, and that drops you in a triangle. Root 3 over 2 is going to be at the cosine, so it would be 30 degree. So you're at pi over 6. And that's your reference angle in the first quadrant. Cosine is positive also in the fourth quadrant. I was thinking sine for a second. And that would be 11 pi over 6.
Okay.
Yeah, go. What do you think I'm going to factor out? All right, factor out the cosine right away. So where is cosine of x equal to 0? And where is sine of x equal to 1 over root 2? Cosine being 0 is going to happen on a quadrantal. You have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Remember, cosine is your x. So it's at pi over 2 and 3 pi over 2. I'm looking for cosine being 0. Okay. If it was sine, yes. Now, sine being 1 over root 2, which triangle does that drop me into?
45.
Drops me to the 45s. So that's a pi over 4. And sine is positive in first and second. So we're at pi over 4 and 3 pi over 4. So those are my 4 possible solutions for these problems. Okay. Yeah. All right. Yeah. Just asking. I get concerned. You got a dollar?
Honey for your thoughts. I can pay that for them.
I'd gladly pay you Tuesday for a hamburger today. Who said that?
John, he got London before he was shot.
Too soon.
Too soon.
Too soon. What do these guys have in common? Tangent. Palm. Palm. If I drop the tangent, we have 3 tangent squared x minus 1, 0. So where is tangent equal to 0? And tangent squared is 1 over 3. So whereas tangent of x equal to plus or minus 1 over root 3. Again, now I'm looking at, I'm not going to rationalize that denominator because I don't need to. Tangent being 0 is when, well remember, tangent sine over cosine. Tangent being 0 is going to happen on a quadrantal, so you're at 1, 0, 0, 1, negative 1 and 0, and 0, negative 1. In order for tangent to be equal to 0, sine had to be 0, because cosine could be either 1 or negative 1. Where is sine equal to 0 on your quadrantals? Pi and 0. So I know that at 0, this is going to work at 0, and it's going to work at pi for these two solutions there. Does that make sense for the tangent?
Could you do 2 pi?
No, because if you think about your interval is given to you as between 0 is less or equal to x, which is less than 2 pi. So I wanted you to stop before you get back to 2 pi. Does that make sense?
Yeah.
Now, with the 1 over root 3, which triangle does that get me into?
30, 69.
It's the 30-60.
And then it's the 30, 0.
So 1 over root 3 is at the 30. So I'm at pi over 6. And it's looking for every single angle in every quadrant that has the reference angle of pi over 6. This is the easy one then. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So in this case, you have 6 possibles. Yeah.
What'd you do with the tan x equals 0?
Quadrantal. Tangent is sine over cosine.
Okay.
Why is
So,
it?
what is-
Y over x.
Sometimes it can be 2 pi or it won't be. Or it can be
Every single assignment has always been in the revolution of between 0 included, not included 2 pi. I would not change it on you tomorrow, unless I wanted to be a really, really big jerk. I could change. Don't nod in it. I could change.
One person's test.
Yeah, I could draw it on one person just to annoy them. I could change the parameters between 4 pi and 6 pi if you want.
How about like
Please
a-
don't.
I like that
Yeah, then you
Yeah.
get extra credit points.
We write a song for extra credit
I know we didn't
on
have to
the,
put a number
on the
in today,
math.
but you won't be a jerk and put something like that on the spreadsheet.
I don't remember even what it looks like. Use a graph. No, because I'm not letting you use a calculator.
Good testament.
So you're right. I won't be a jerk. Yay! And you know what? The Masters are on tomorrow. It's a great day. I can't be mean on that day.
You play golf?
You're always like a
girl.
Got the pad.
Are you good at golf?
So
My
bad.
parents play golf.
But that's actually.
Okay. Make sure that your names are on the work on this one. Save the worksheet so you can continue if you want to work on some more of those. I'm going to use the next little bit of time here to kind of go over a couple ideas from the test itself.
Will you put up what is on the test? Yeah, you wanna just you wanna just put up.
Yeah, I'm just going to go through a few. Yeah, let me open the folder for you. Let me get this out for you.
What are we doing? Oh, you're showing us the answers?
Yes, the answers to the first one is 6, 2 pi, root 3 over 2, and then it's sine
Can I take a picture of that?
plus cosine,
Because you can use your phone.
and then it equals 1.
Wait, are we paying?
I'm not lying, those are the answers.
Oh, with your
You paid this?
I do.
Are we passing this out?
Yeah.
Don't give that back.
Oh, yeah.
All right, so we go.
Did it.
Amplitude and period. When you're dealing with amplitude and periods of sines and cosines. Come on, guys.
Collective. You're failing at your job.
Remember, when you're dealing with sine and cosine, they both have the exact same generic formula. They both have the same generic setup. She's so mean to you.
You're in everyone, not the person.
I know, she's a big bully.
She just keeps on there.
Oh, it's not me.
You know, why do you leave? We're all nice to you.
Yeah. Seriously.
Everyone's fighting their own battle.
Remember, when you're dealing with sine and cosine with graphing stuff, your A value will give you your amplitude by their absolute value. Oh, I have a pile back there, so sorry. Your B value works with the period. How do you find the period of sine or cosine?
2 pi over b.
Very good. It's 2 pi over the absolute value of B. Remember, the worst thing that can happen with sine and cosine, if you're working with these things, is that that B value sometimes gets hidden in the parentheses with the H. I think we had a couple of them like that where you had to factor something out. It wasn't anything. Remember, your H and K denote your horizontal and your vertical shift. When you're graphing these things, just like you guys did on that quiz, which you guys all did really well on, the worst thing you ever did on that was you flip-flopped an A value, and that was about it. Remember, you always plot your parent function first, and then you shift your H and your K. So what I'm going to do real quick here is just do a real fast sine or a cosine, and then one tangent, and then I'll continue with the other stuff, okay? Let's see, I did a I'll do a cosine. So I'm looking at graphing a real simple cosine problem. Remember what we always did is we always labeled out our stuff, our A, B, and our H, and our K. So I have 6 plus 4 times cosine times quantity x minus pi over 2. When I get this far, what I want to make sure I do is just label out my stuff. A is 4, B is 1. Now, is H can be a positive pi over 2 or a negative pi over 2?
Positive.
It's positive, very good. And K is a positive 6, which means everything in this case is going to get shifted to the right, pi over 2, and up 6. My A value is 4, therefore my amplitude is, and my period is 2 pi. Very good. So cosine. My A value is 4. I know I have a shift of 6. So I'm just going to put those in now just so I have a little bit of space. Period is 2 pi. Put in your markers. Cosine. Does cosine start at A or does cosine start at 0? It starts at A. Okay. Cosine starts at A. This A value is positive, so that means I start at a positive 4. And I work my way through. 0, opposite of A, 0, and then back to A. Yeah, sine starts at 0. Very good. Now, to each of those points, I have to move them right, pi over 2. Well, what's nice is that my first set of periods are all blocked off in pi's over 2. All I have to do then is make one more tick mark for the 2 pi. I add pi over 2 to 2 pi, and I get 5 pi over 2, I believe. And all of those points need to get moved up 6. So instead of being at 0, 6, or 0, 4, excuse me, I am now at pi over 2, 10. Instead of being here, I move over 1, and I go up 4. No, up 6, excuse me. And up 6 gives me to 2. Over 6, and then over back to 10. And again, graphing of these was very easy. You guys did really good on these. Okay, you did really well. You should not have any issues whatsoever with this. You're able to break them down into the groupings, take the halvesies. You never had an issue with this. The only difference between sines and cosines versus the tangents is that your tangents are not continuous graphs. They have what? They have asymptotes, and their period is a little bit different. The period for tangent is found by how?
Pi over, it's just pi, not 2 pi.
It's just pi over b. So if I'm looking at something like this, tangent goes one of two directions. It either goes up and right or down and right. When does it go up and right?
It is positive.
If A is positive. Think of it as in terms of slope. If your slope is positive, it goes up and right. If your slope is negative, it goes down and right. Treat tangent like that as well, and you'll be okay. So I have 3 plus tangent times quantity x minus pi. This gives me an a value of 1, a b value of 1, an h value of pi, and a k value of 3. Yes, sir?
Where would the B go if there was
I'll show you. So your period, the b value doesn't really get you anything except for dividing it by pi.
like in the equation?
Oh, b?
Is it right after the
Yeah. It's a tangent b. Everything else is the same. Now, if my period is at pi, where do I place my asymptotes? Yeah. Remember, your asymptotes go halfway of the period. Tangent always starts, will always go through the origin for its parent function. Half the graph is on both sides. It's symmetrical. Pi over 2, negative pi over 2. Here I have an h of pi and a k of 3. Your a values, they are not amplitudes and tangents. There is no maximum height level for a tangent. That a value here tells you where it's changing direction. It's a point of inflection. It's where it changes. Now a is positive, so moving up and right. So I've got the point at negative pi over 4 and 1, 0, 0, pi over 4 and 1. I'm just doing that curve. Again, when you are working with tangents, when you go to shift, it's usually easier to shift your asymptotes first. So if I'm shifting from negative pi over 2 right pi, what does it become? Pi over 2. So I have a new asymptote at pi over 2. If I shift pi over 2 to the right pi, it goes to 3 pi over 2. The negative ones?
No, like how does the
Asymptote?
yeah,
The asymptote, our period is at pi,
right.
and our original tangent graph always goes to the origin. So if it's going to be here, half of the graph is on one side, half of the graph is on the other. Okay. So now my new origin, instead of being at 0, will be, if I move it to the right pi, it'll be at pi. So we can put that in as pi. Here and here we'll have, what was it, 3 pi over 4. And then this would be 5 pi over 4. Instead of being at 1, I move it up 3, so it's going to be, or excuse me, negative 1, so negative 1, 0, 1, 2. Oops, gotta be over here. There's 3, and there's 4. There's your new curve.
I like these curves.
Tangents are nice and easy. As long as you get the a value correct, it's a piece of cake.
What's the period again?
Pi over b. Pi over b.
Right.
It's the only thing that's different, and plus it has the asymptotes. Because you can think about it on the unit circle, as you're going from 0 to pi over 2, it becomes undefined. As you're coming back down to 3 pi over 2, it's also undefined at the 90 and the 270s. That's why there's asymptotes. Yes, sir?
You have to draw like a new origin so to speak, like a pi.
You don't have to, but
Just easier.
yeah, sometimes it's easier to do that. Yeah, I find it'll be easier sometimes to throw it in there. Other than this, guys, I mean, you've done every single simplify and verify that I can think of, except for the ones that are on the test. I had to save a couple of problems not to give you, so that way I had something left over for the test. So you've got those. Then you have your solve general and your solve within your one revolution. To be honest with you, you've done just about every single problem that I could think of and that I could find that I've done that's out there, except for these 11 questions that I have on the test.
It's only 11.
It's 11 questions. I've done every single other problem known to man that I could possibly find for you guys, except for these 11. All right? Now, you've got tons of information as far as all those extra worksheets and stuff, the simplified problems. You've got your book. It's got the chapter review. The chapter review kind of sucks when you're looking at the simplify verify, because there's a ton of negative angles and half angle stuff. That's when I would kind of fall back on those worksheets and things that I was giving you guys, just those extra practice ones. The simplify and the solve within the revolutions. You guys, you're doing really well because you're really good at reference angles, so that shouldn't come as a shock to you with any of those. Just remember to set aside equal to 0. Sir?
We won't have to simplify the negative x's like sine of negative x.
No.
Okay.
We never did it in class, I'm not going to make you do it tomorrow. Okay? Other than that, I mean, we kind of cruise through. I mean, you should do really well on this, and we've spent a lot of time on it. One of the most difficult chapters that we have. Yes, sir? 1 million. No, I'm sorry, it's 1 billion.
Really?
Yep, because if you get 50% of 1 billion, it's only 500 million.
That can raise.
It's still a 50%, isn't it? Point value doesn't matter because grades are weighted. Okay.
Jack and I dissected.
You forgot what?
We dissected what the test is.
What is it going to be?
A cos graph,
Okay.
a sine graph,
Okay.
I think you
a
might have.
tangent graph,
Okay.
and then we said
That's 3.
To verify.
2 verify, so 5.
verify.
That's 7.
And then 2 general, 2 in between the.
So you're at 11.
I mean, that was a good guess.
That's a good guess.
Regardless, I think it's gonna be.
Nailed me.
You're in between.